Hello, welcome all. Today we'll see that how to we interact with the PDF content. Okay. So this is the workflow which I have given. So we do have a PDF content. So this PDF content, with the help of LangChain, we will be um, converting this PDF data into multiple chunks. So chunks means nothing but chunk. See, based on the chunk size and chunk overlap, whatever you provide. So based on that, the chunk will be created. See, assume chunk size is 500. You means if you are giving each 500 characters will be stored in one particular chunk, and the next chunk will be having another 500 characters. Then, so like that, the entire document will be splitted into n number of chunks with a split of 500 characters. Along with chunk size, you give chunk overlap as well. Chunk overlap is nothing but each chunk, how many characters should be overlapped. See, assume that if you are giving chunk overlap 100 means the initial chunk will be having 500 characters, and the last 100 characters of chunk 1 will be the starting of chunk 2. So the first 100 characters will be from previous chunk, and the another 400 characters will be there in the this chunk. New characters will be coming. The next chunk 3 will be having 100 characters of chunk 2, and then the remaining. So like that, it will be going on. So this is the overall procedure. So all the text document will be completely converted into chunks, smaller chunks. Okay, so that's the chunks. Once chunk is created, using HuggingFace embedding, will be creating the embeddings for each of the chunks. Using PineCone index, the embedding will be having a vector space. So each embedding, the chunks and the embeddings, right? So it will not directly be stored in the same format. It will be converted into vectors, and those vectors will be stored in the PineCone index. And then whenever you ask a questions, it will reach out to embeddings, and the embeddings will search the vectors, and finally you will get the results. So this is the overall picture. So whenever you search it, it will go to vectors, and the vector will give the results. So basically, if you how many k you are giving, based on that, if you are giving k equal to 5 means 5 results will come. So the ranked results will come, and finally you can see the answer. So that's the overall picture. So your PDF content will be converted into chunks, and the chunks will be stored in embedding. I mean, chunks will be converted into embeddings, and the embeddings will be stored in the index or vector database, and finally you will interact with that. Okay, so that's the overall picture. So before that, before starting to the code, let us first create the one index, so that we'll get to know. So let me create one index. What is there in the code? Let me use the same. So index. Okay, so this is the index name I'm giving. So dimension. So what is the dimension that you need to give? Let me show you that. So here is the thing which is there. So this sentence transformer, this is the model which we are going to use. So this is the model which we are. See, this is the model sentence transformer, which is the model which we are. Sorry, all mini LM L6 V2 is the model which we are going to use. So that has a 384 dimensional dense vector. Okay, so we are going to use this 384 dimension. And matrix is, you can see that cosine dot product Euclidean, anything you can use it, but currently we are going cosine. So cosine is generally, see, it's if you hover here, you can see understand that what is it. See the distance metric to use for measuring similarity. So that means if similarity, I mean, if the distance is 0 means it is similar. If the distance is far, then it is not similar. It means it is not same. So that's the thing. So how exactly this will be calculated is, see, let us see here. See, this is our one example I have given, plotting area, this is the one plot, and another one thing, point, 2 points are there. So when you calculate the distance, so cosine, how it will calculate the distance is, it will draw a line to the origin. So from the origin, it will uh, draw an angle. So see, it will from x-axis to y-axis will draw a line. So this is the first thing. So if you look at this angle, and the second one is the distance between these two things is this line. So the common is this portion. This is the common portion, and this is the actual difference. So that means this is the distance between these two points. So this angle is the distance. That means whenever you say that it is angle means, so that see, cos 0 means 1, cos 90 means 0. So the similar way, based on that, cos 0 means 1 means, if cos 0 equal to 1 means, whenever you say the distance between these two, if the distance is 0 means if it is similar. If the distance is more means it is not relevant. Okay, so that's the thing. So this angle is the actual difference or distance, whatever you can see. So that's the cosine. So that's why we are giving this cosine as a metric. You can give anything including also, then the calculation might differ. So we are using cosine here. So let me create the index. So this PineCone is giving you a starter free, which will be having one index to one project which is free. So I'm going to use this. So yeah, index. So let us getting initialized. So meanwhile, we'll go to this code actually, what it will do is. So coming back to here, so first thing is PDF content. Okay. So I have given that whatever the necessary things that we need, I have installed here. So LangChain is required. So why LangChain is required is, LangChain is the only one which is providing this document loader and all. You can see here document loaders. You can see LangChain, what is the API things, and you can see here document loaders. Okay, it has a PyPDF. Okay, so PyPDF loader, which needs a file path. That's it. Okay, so what I have installed is I have installed a LangChain. I have installed PyPDF, and then unstructured, just I have given that. Okay, sentence transformer, which is required to get the models. Okay, and then PineCode client, why it is required is I have shown that we have created a index over here. So it is now, it is green. Okay, good to go. Okay, so this PineCone client is which is required for to interact with the index, and HuggingFace hub, which is required for question and answer models. Okay, so that's the overall thing. So another thing is okay, so let us run here. This is as I have already on time run. It says that recommend is already satisfied. So it will take quite a few time. But a few minutes, it will take quite a few minutes. So yeah. So it will install everything. Okay. Okay, it's finished. Now next thing is, what I'm doing is from a LangChain document loaders. Okay, as I told that PyPDF is loader, which we need to load the PDF file. And the text splitter, which is required, why we need to do is, as I told, we need to split the chunks, right? So for that, text splitter is required. So, and then embedding, as I told, we need to create the embedding. So I have given this the third thing's embedding. And vector stores, as I told that we need to create the vector stores to store all the embedding. So we have given that vector stores. Sentence transformers, why we need is sentence transformer is the one which is using model here. You can see the below. So this model is coming from sentence transformers. Okay, so that's why we have given sentence transformer. And then LangChain. So this is question and answering model. So for that, I have given that. And then import PineCone is, as I told that, it requires for index. So PineCone I have given. And import OS to store the environment variable. So it's okay. Okay, so that's why I have given. So let us run that. Okay, it's finished. Now next thing is PDF loader. We have to give the PDF file. Okay. So before that, I'll first drag and drop the PDF files. Let me load the PDF. Okay. So I need to give the file path as in this big document, right? So I have to give the file paths. Okay. So I have given here. So just right click, copy path. You can give here. Okay. And then loader.load will load the uh, all the entire data will be entire document will be loaded in data. It's okay. Let me run this. Here. Okay. Invalid argument. Load. I guess it is. Sorry for that. It is not fully encyclopedia is not fully copied, so that's the reason I guess. So let us wait for this to completely build into that. So we'll wait for to get into the files. Okay, so even though it is being here, it shows that it is not fully copied. I mean, it is fully dropped in the location. Okay, so it is. Okay, it is fully copied. Okay, now let us run that. Okay, it will take some time. So let us okay, can see here the process executing 19 seconds, right? Executing 20 seconds. Okay, so I'll pause the video. It will let me connect back once it is ready. Okay. Okay, so before that it's ready. Okay, good. Okay, so this is ready now. Next thing is, so I have loaded the PDF. Okay, next thing is I'm going to split it into multiple chunks. Okay, so this is recursive character text split is the one which is uh, we are going to use. So the chunk size is 500. I'm not using overlap because this is a very big a document which is having close to 600 pages, and it is having 15 MB file, and it is um, having around 637 pages. So I didn't give any um, give overlap. Okay, so that's the thing. So text splitter will be having. Okay, the next thing is after text splitter, I'm going to split the document. Okay, so what I'm going to do is, see, this is a chunk size is 500 and chunk overlap equal to 0. That's the definition which I have given. And then I'm going to, whatever the data which is loaded here, right? So this data I'm going to split it. Okay, so that's the thing. Okay, so now it's done. So let us see that what is the length here. Print length docs, how much chunks it has been created. Let us see that. Okay, 7,008 chunks it has been created. Let us see the first chunks, whether it is clearly given or not. Okay, so this is the thing. Okay. Okay, that's so you can see here. Okay, so I have created the document, which has got split into multiple chunks. So the next thing is HuggingFace API token. Okay, so this is the thing. Okay, so this is why we need this. We need to download the models, and these two why we reckon is we need to interact with the PineCone. So how we have to create the HuggingFace API tokens. Okay, so this is the thing. So okay, you can create a token. It's a free thing. You can create a token and PineCone, as I told that. PineCone also. How you create a token is. So here API key. So this is the environment and this is the value. Okay. So this is the thing. So okay, you can see here. Okay. That's the thing. Okay. So this is the thing. Okay. That's what I have added over here. Okay. So that's what I have added over here. Okay. This is the HuggingFace token, and this is the PineCone API key, and this is the environment. So all the three I have given. Okay. So this is the thing. Okay, which is added. So next thing is, let me download the model. So the model is downloaded. Now, next thing is related to PineCone. Okay, so this is the index which I have created, right? Let me show that how to connect it. If you go here, connect means it will tell you that, okay, this is what we have installed in the very first step, right? Okay, next thing is, so how to do this. Okay, this is import PineCone, which I have, which I did in second step. Okay, this is next thing is, this is the way it is going to connect it. Okay, so API key, environment, and index is what we are going to use it. Okay, now first thing is, let me show that index before. So this is the way it is going to connect it. Okay, so if you go here, okay, so 0 vectors are there. Okay, now let us let me. Okay, after that, what I'm going to do is, so this is the way I created. API key is given, and environment is given, and then index name is given. Okay, so then it's done. Okay, so next thing is doc search, which I'm going to use. Okay, so before that, I'll tell you that this will look everything. So this will it will take some time. So, okay, let me run this. So what it will do is, see, from text, if this is all the things will be stored in a converted into index. Okay, so let us see here again. It will take a little longer time because since it has been a very lengthy document. So let me pause the video. Once it is done, I'll connect it. Okay, so this doc search step has completed, and it took 16 minutes to load that. Okay, that's fine. So now let us take this drag or this. So this is the question, and you can give three ranks. Okay, so let us um, take the first three results. Okay, but anyway, I'm not printing that. So first two results I'm going to join and give it to you. Okay, let us see that how it is. So this what it does, that is, if you remove everything here and if you print the ranked chunks, then it will print the first three results. So let's say, let us see. Okay, so metadata 1, metadata 2, and metadata 3. So you can see here. Okay, so this is the thing. Okay, the result may be in regular heartbeat. It will, if the heart is beating too fast, this drug will slow it down. Okay, so that's the thing. Okay, now we'll go here with the actual thing. Okay, so this one. So now next thing is commenting this. Let us run that. Okay, so while joining that, what is the score we'll see. Okay. Okay, so what exactly I'm doing is three results I'm getting. So from the three top two, ranked two, I am taking. So I'll top two ranked chunks I'm going to use that, and I'm joining that, and then the score is nothing but this is a model which I'm going to use, and this is a query which is query embedding means my query, and combined embedding means my answer. So we'll pass the cosine similarity, we'll get the similarity score. So query embedding and combine both we are passing, and then we are getting the similarity score and printing it. Let us see. Okay, so this is the answer. Okay. For people with asthma, the simple act of breathing use erythromycin doesn't show. So this is the thing. So anti-arrhythmic drugs or medicines that correct irregular heartbeats and slow down. Okay. So let us see here anything is there. So you see this is anti-arrhythmic. This is irregular. See medicines that correct irregular heartbeat and slow down hearts that beat too fast. So that's the thing. Okay. Definition is the okay. So anti-arrhythmic drugs or medicines that treat or prevent asthma attacks. So this is given purpose for people with asthma. So this is things somewhere it will be there, I guess. Purpose will be there. Okay, somewhere it will be there. So that's the overall thing. This score is 68. Okay, while combining. Okay, so that's the thing overall. Okay, right? So we'll show you that final thing. Okay, so PDF content we loaded and we have converted into chunks, and finally using HuggingFace embedding, we have created embedding, and using PineCone index, we have what do you say? We have created vector space, and while questions is asking, it will reach out to embedding and it will search it and it will give you results based on your numbers, k number. Also, that's the overall thing. So, okay, in the next session, okay, this is in Colab we are doing now. How to get it in web page, like using Streamlit or any other thing. So we'll see in the next session. We are just asking the question and how we are getting the answers. So that we will try it in the next session. Okay. Thanks for watching this. If you have even I'm new to this area, so if any suggestions or anything, if you have questions, just to post it. I'll try to find out the answers. If I don't know, I'll get back to you. Thank you.